So this is the site fed.colorado.edu. And if I, so if I show you the solution, show you just a demonstration. As you can see on the right end, there is a fixed end. Okay, those just joining in, I didn't teach anything so far. I just clarified a few doubts. We are discussing the homework question, which I had given from my class notes itself. Okay, so just see if I create a pulse, see how it gets reflected from a fixed end. Okay, so if that was getting damped, I mean, it was losing energy. This is how it should look. This is how it gets reflected from a fixed end and undergoes an inversion. Right now, at the moment, both ends are fixed. The left end is also fixed, the right end is also fixed. So each reflection is getting inverted. Okay. On the other hand, if the other end is loose, look at that. Let's slow that down. See, no inversion when it gets reflected from the free end. There is an inversion when it gets reflected from the fixed end. Again, no inversion from the free end. Again, an inversion from the fixed end. So this is basically similar to the homework question I gave you. Okay, free end, no inversion. Let's speed that up. Free end, no inversion. Fixed end, inversion. So you can maybe note the site down. PHET, Colorado.edu. You apparently have some more stuff from physics and I think from other subjects as well, which you can check out if you want. Okay, so that illustration exactly in a way describes the question we're going to do now. We wanted to find the minimum time taken by the string to regain its shape. So that's like the first time it regains its shape. Okay, and then the second and third time it again regains its shape. Shape of the string has to be regained, not just the pulse. I'm not waiting for the pulse to be upright again. I want the string to be the exact same shape. So I need an upright pulse at the exact same position again. When, not a different position, exact same position. When that happens, we'll say the string has exactly regained its shape. So if you look at the way the motion proceeds now, I think with the help of what we just saw, you can visualize what's going on. At t equal to 0, it's starting its journey. Okay, velocity is 20 centimeters per second. All right, so every second, this is going ahead 20 centimeters. So in 1 second, the pulse will be here, 20 centimeters aage. In another second, the pulse will be back over here. Okay, so in 2 seconds, the pulse is going to move 40 centimeters. In 2 seconds, the pulse is going to move 40 centimeters. Okay, it's going to be an upright pulse. Why is it going to be an upright pulse? Because it got reflected from the free end. So it's going to be an upright pulse. And that's the first occurrence where you see an upright pulse in the exact same position, therefore the same shape of the string. You see that again take place the first time in 2 seconds. Okay, in 2 seconds. Okay. Uske baad, 1 second later, it again moves 20 centimeters. So 1 second later, it's moving 20 centimeters. मतलब 10 आगे जाके 10 पीछे आएगा. But this time, it's going to be an inverted pulse because it just got reflected from the fixed end. So at 3 seconds, you see an inverted pulse. This does not qualify as the second occurrence of the string regaining its shape because obviously the pulse is this time upside down. It's inverted. So let's wait for it to become upright again and be at the same place. So 1 more second, if you wait, it will move 20 more centimeters. It will reach that end. And then 1 more second, it will move another 20 centimeters and be back over here. So from t equal to 3, if I wait for 2 seconds, it's going to go ahead and come back. And this time it will be reflected from the free end. Therefore, it will stay inverted. It will stay upside down because the free end does not invert the pulse. So this time this is upside down. It will stay upside down. So at t equal to 5 seconds, it's still upside down. Iske aage, if I wait for 1 more second, तो ये और 20 सेंटीमीटर कवर करेगा, मतलब 10 सेंटीमीटर आगे जाके 10 सेंटीमीटर पीछे आ जाएगा. And this time it got reflected from the fixed end. So if it got reflected from the fixed end, in 1 second, if it got reflected from the fixed end, you should now see an upright pulse. Okay, you should see an upright pulse because the fixed end will invert whatever this is. So this is now exactly again matching the condition given to us in the beginning. Pulse is 10 centimeters away from the left end and it's upright. So it's at the same place, same shape. Therefore, the entire sinker shape is repeated. Therefore, 6 seconds was the second time the string regains shape. Okay. Wait for another. So another second means the pulse will be there. And then one more second after that. So a total of 2 seconds from t equal to 6. The pulse will again be over here. And because it's getting reflected from the free end, it will not get inverted. So at t equal to 8 seconds, you will see an upright pulse again at the same place. So that's the third occurrence. Okay. Did everyone understand that? How many of you were able to get this at home? It's an easy question. You just, of course, need to accurately visualize. Yeah, you just need to visualize. That's all. The calculations are only distance is speed into time. So you just need to visualize, and you have to use distance moved is speed times time. Right now this is a pulse, so I wouldn't call the motion of any particle an SHM. It's just a pulse. The motion of each particle is dictated by that triangular pulse. So each particle, whenever the pulse reaches it, they go up and they come down. So it's not an SHM. The shape of the graph also is not sinusoidal. Okay. Cool. Anyone wants me to wait over here? No? Okay. All right, so we'll move on in 5, 4, 3, 2, and 1. All right. So now, okay, we're going to see something a little bit more interesting. We're going to see what happens when your pulse tries to go from a particular string of a given material to another string of another material. Okay, so these two strings are joined to each other. Okay, I've colored them as the black string and the red string. The black string ka refractment next thing. Black string ka linear mass density is mu, and the red string ka linear mass density is mu dash. Okay, so you have mu and mu dash. We are seeing what happens, how the wave gets reflected and transmitted as it goes from one string to another. So you can recall what happens with light, right? When light changes media, it undergoes a reflection at the boundary. It also undergoes a refraction, right? So in light, as the medium changes, you have reflection and refraction. In other words, reflection and transmission. Sound itself also undergoes reflection and transmission, right? When you talk in a room, you hear the reverb coming from, so you you have the concept of reverb, which is taking place because of sound bouncing off the walls and interacting with the sound you're producing. So it creates a different kind of effect as opposed to what you would feel when you're in a hall or what you would feel when you're in an open ground, right? So that effect, the difference in sound that we hear is reverb, and that's taking place because of the reflection of sound from a boundary. So you know that sound gets reflected. You also know that sound gets transmitted. Somebody is screaming in the other room, you can hear it in your room because sound gets transmitted through the walls as well. So similarly, okay, over here, wave gets transmitted and reflected as soon as the medium changes. As soon as the medium changes. What we are going to try to figure out is what we're going to figure out is what will be the equation of the reflected and the transmitted wave given the incident wave. Okay, so all of what we're going to do now is going to be quite interesting, and with this we can also prove the results we saw for a fixed end and free end. So with this we'll work out the maths, we'll work out the physics, and then we can prove the results for fixed end and free end. Okay, this is linear mass density. So if this is incredibly heavy, if mu dash tends to infinity, it's going to be more or less like the pulse bouncing off a fixed end. If this is going to be incredibly heavy, the red string is not going to move at all. All right, so it's going to be almost like the pulse bouncing off a fixed end. So that's how we plan to prove the result. And if mu dash tends to 0, this is going to be so light that this is going to offer no resistance to this guy when they interact. So it's going to be almost like reflection from a free end. Again, I'll talk about that as we proceed. But that's the plan. That's how I plan to prove the results for fixed end and free end. Now, a couple of things that you should immediately realize. Okay, sorry. First thing is both strings have the same tension. Okay, both strings have the same tension. Obviously, that comes from Newton's third law. Okay, both strings have the exact same tension. Why? Newton's third law says कि अच्छा ये string उसको खींचेगा अपने tension के साथ, वो string लाल string काले string को खींचेगा अपने tension के साथ. Newton's third law says कि the action and reaction are equal in magnitude. So tension P and P dash are equal. So both strings are going to apply the exact same force on each other, right? And you guys know this anyways. Tension when you have strings in series or springs in series, tension in all of them are the same. Tension is the same. What else is the same? The other thing is the same is omega. Okay, omega is the same because why is omega the same? By the way, omega as an extension also implies frequency and time period is the same. So you might remember we mentioned in light waves ki when light gets refracted, we mentioned in optics, as light passes from one medium to another, speed changes, lambda changes, frequency never changes. We had mentioned that then. Okay, even if somebody is singing from the other room, you will hear the same note. Frequency is not going to change as sound also gets transmitted from one room to another. And frequency for this wave also will not change. Why? Because think logically of this point of contact. Okay, the left end of this point of contact and the right end of this point of contact more or less have to be at the same place at a given amount of time. They're close to each other. They can't be miles apart. They have to be at the same place. So when the left end of that point of contact goes to the positive extreme, right end should also go to the positive extreme. When the left end comes to the mean position, right end also comes to the mean position, and so on and so forth. So they have to oscillate together in harmony with each other. They have to, at least the point of contact ke jo baaju mein molecules hai, they have to oscillate together, right? That cannot happen if their frequencies are different. सोचो frequencies अलग है तो यार जब तक ये extreme पे चला गया तो मान लो ये ऐसा oscillate करके इधर चला गया. Is that possible? कि black string का एक end ऊपर है, red string का एक end इधर है, and they're supposed to be joined. That's absolutely not possible. So that's the logic, because those points have to move together in phase with each other. That's why the frequencies have to be the same. So frequency never changes as the medium changes. Okay, frequency never changes as the medium changes. So these are what are the same. Very important for you to know what are the same. इसमें ना जो हम रिजल्ट निकालेंगे उसका ऑफकोर्स एक अंत में मैं अच्छे से एक एल्गोरिथम दूंगा, तो ये निकालना बहुत इजी हो जाएगा थ्रू द एल्गोरिथम. But that said, all of the steps that we're going to follow in the derivation are also important, because any theoretical question can come. They can ask you, does tension change? Does omega time period change? How does K change? So all those conceptual questions, theoretical questions can come, which is why the derivation is as important as the final result. Okay, so I hope you guys got this. If you have any doubt, please ask. Moving on to the wave number K. to find K, okay, to find K is going to be omega by V. All right. So we know that omega is not changing. So K is inversely proportional to V. K is inversely proportional to V. Okay, fair enough. But V is root T by mu. So 1 by V can be written as root mu by T. Tension is constant. Omega is constant. That is what makes K directly proportional to root mu. K is directly proportional to root mu. K is directly proportional to root mu. All right, so that is going to be one important equation. Just to visualize K is 2 pi by lambda. So you guys all visualize greater lambda as a wave where, I mean, where the wavelength is more, where you see fewer repetitions. Naturally, a diagram like this will have smaller lambda. So K lambda के inversely proportional है. Okay, तो ज्यादा K मतलब छोटा lambda, ज्यादा K मतलब छोटा lambda, कम K मतलब, गलत बोल रहा हूँ, सॉरी, हाँ, ज्यादा K मतलब छोटा lambda, bigger K smaller lambda. So this is bigger K, okay, and smaller K means bigger lambda. So this is smaller K. Okay, bigger K, smaller K. Okay, bigger K में you will typically see bigger K for greater mu. So if the string is heavier, you'll see it have smaller wavelengths. The string is lighter, you'll see it have larger wavelengths. Okay. Anyways, that visualization is not absolutely necessary, but just if you have to visualize, you can do that. Just remember K is 2 pi by lambda. So accordingly, you can visualize how the string will look. Yes, I'll just talk about that. Okay, so now let's see how we're going to write our equation. Okay, so let's say I am given the incident pulse ka equation, yeah, incident wave ka equation. Okay, this is our sinusoidal traveling wave. The incident wave ka equation is given to me as amplitude sin kx minus omega t. ये ऐसा equation दिया है. Okay. Now, couple of things. Why R represents the reflected wave. So this is going to be a wave which gets reflected at the boundary. तो वहां से reflect होके अब ये वाला wave पीछे के direction में जाने वाला. So YR is the equation of the reflected wave, and YT is going to be the equation of the transmitted wave. R is for reflected, T is for transmitted. So what do we observe? Okay, so some change in amplitudes is what we will observe. Okay, AT और AR ऐसा कुछ नया amplitude आएगा. They could be negative as well. हमने देखा है कि reflection from a fixed end में उल्टा हो जाता है, तो maybe the amplitude can be negative as well in certain cases. Okay, but AR and AT basically are some constants which will in a way represent the amplitude. And if they're negative, they'll also tell you whether the pulse gets inverted or not. तो वो एक है, AR और AT निकालना सीखेंगे. दूसरी बात यह है कि sin kx, now notice the reflected wave is in the same medium as the incident wave. Reflected wave is in the same string as the incident wave. So if it's in the same string, it has the same mu. If it has the same mu, it has the same k. All right. So therefore, reflected wave का wave number exactly same रखूंगा जो incident wave में था. So I'm going to use the same k. But obviously for the transmitted wave, I will not use the same k because the transmitted wave is now in a different string, is on a different string, जिसका अलग linear mass density है, अलग linear mass density के कारण अलग k है. So therefore, I will use the symbol k dash for that, and we learn how to find k dash as well. In fact, k dash ratio proportion से आ जाएगा, है ना? K is proportional to root mu. तो वहां से mu और mu dash दिया है, k दिया है, तो k dash आ जाएगा, ठीक है? So the transmitted wave has a different k. So that's one thing we observe. The other thing we observe is they all have the same omega. Okay, so all have the same omega. Frequency does not change. ओमेगा सबका सेम है, okay? ओमेगा सबका सेम है, ओमेगा को साइन से फर्क नहीं पड़ता है भाई, ओमेगा इज जस्ट mod of the coefficient of t, so that magnitude is the same, coefficient of t का magnitude सबके लिए same है, because frequency does not change as the medium changes. All right. Last thing is the transmitted wave goes in the same direction as the incident wave. So transmitted wave में I will not change the sign of any of these terms. Okay, right now the terms are of opposite signs, implying the wave is going towards the right. Here also they will be of opposite signs, implying the wave is going towards the right, because transmitted wave means it's going in the same direction, right? So I will not change any of the signs. I want a wave to continue to go towards the right, so I'm not going to change any of the signs. ये जैसा लिखा है वैसा का वैसा transmitted wave का वैसा का वैसा ही transmitted wave दिखेगा. The only change will be k की जगह k dash. That's the only change while writing the transmitted wave. Writing the reflected wave, okay, we now of course we want a wave going in the opposite direction. तो किसी का तो साइन चेंज करना है, दोनों का नहीं करेंगे, दोनों का करेंगे तो सेम डायरेक्शन ही आएगा, है ना? तो ऑब्वियसली दोनों का नहीं करना है, एक का करना है. एक का साइन चेंज किया, then they will go from being of opposite signs to having the same sign. I said if the coefficients have the same sign, it represents a wave going towards negative x. This represents a wave going towards positive x. So I need to change one of the signs. This is where I need to mention what I had mentioned earlier. While changing the sign, please change the sign of omega. Don't change the sign of k. Okay, let's see that in this concept. Okay, why do I say change the sign of omega, not the sign of k? Because we are already, first of all, if a phase, if at all an inversion is taking place, we are taking care of that by putting an appropriate minus sign over here. And if no inversion is taking place, we are taking care of that by keeping the amplitude as it is. So we don't need to do anything inside this bracket now to bring out that inversion in the pulse. We are representing that inversion by either writing a positive amplitude, which will imply no inversion, or by writing a negative amplitude, which will imply inversion. तो साइन के अंदर अब और कुछ नहीं करना है इन्वर्ट करने के लिए. Inversion has been taken care of. Whether or not the pulse gets inverted, that has been taken care of. वो amplitude में दिखा देंगे. इसके अंदर अब मुझे सिर्फ डायरेक्शन चेंज करना है, वेव का प्रोपगेशन का डायरेक्शन बस चेंज करना है. You should realize that if I am going to change k, just have a look at that. If I am going to change k, see what equation I get. So I am not changing the sign of omega, I'm only changing the sign of k. Now if you freeze time, okay, if you freeze time, or if you put in the same value of omega t, okay, if you take a snapshot of time, this is suddenly telling me that before reflection, my shape was an a sine kx shape, and after reflection, my shape is again, you can take the minus sign out, you put omega t as 0 for both, it's again an a sine kx shape. All right, so there is no inversion at all. We want it to be a negative a sine kx shape. वो k का वापस minus sign डाल के, it's in a way countering the effect of the minus sign you put over here. All right, so this of course is going to give us a wrong result. The shape of the string immediately after that collision takes place, okay, you can ignore omega t while seeing the shape. Immediately after collision takes place, if I had changed the sign of minus k, I'm actually getting the same shape. I'm not getting an inversion. Actually हो क्या रहा है? All inversions have been taken care of. वो सब करने के बाद, after taking care of the inversions, if you're going to change the sign of the coefficient of x When you do that, you end up changing the shape of the string. Remember, shape only depends on how y varies with x. तुम x के सामने अब और कुछ भी चेंज लेके आओ, स्पेशली ये माइनस साइन डाल दो, you will end up changing the shape of the string. x के सामने तुमने माइनस साइन डाल दिया, in effect you've replaced x with minus x, you are ending up changing the shape of the string. You get the, you see the problem with that. Okay, so whatever, if you change the sign of k, okay, if you change the sign of k, you will end up creating an additional change in the shape of the string, which may, which will counter whatever you have done over here. यहाँ पे ये wider written minus sign और plus sign सोच के लिखा है, वो सब सोचने के बाद ये उसको पूरा destroy कर लेगा. Because if you put a minus sign over here, that's going to completely change the shape of the string. So never change the sign of k. Okay, only change the sign of omega. Changing the sign of omega is harmless. That doesn't change the shape of the string. Because at the same instant, just before and just after collision, these two terms are the same. All right. So when I change the sign of omega, it's just in a way, it's like going back in time. Omega का sign change करने का मतलब ऐसा हो जाएगा कि instead of going forward in time, you're going back in time. So it's going to give that kind of effect. Okay, the same pulse आगे जान की जगह पीछे time में जाता तो कैसे दिखता था, वैसा, that is the kind of effect you get when you change omega. At the end of the day, moral of the story, just change the sign of omega. If you want to reflect a wave, change the sign of omega, because if you change the sign of k, you will change the shape, and you don't want to keep track of that. Okay, you don't want to keep track of that. हाँ, तो कोई बोल रहा है कि सर ये करने के जगह मैं minus k करता था. Yes, so that's one option. Instead of putting the minus sign inside, you could have maybe changed k by minus k, but then it's you don't want to keep track of that. Okay, let's not let's stick to just changing the sign outside. This is more nice, more visible to the eye. So if you're getting an inversion, put a minus sign over there to start with. Don't change the sign of k. This will keep things simpler. So you don't have to think too much about trigonometry. क्या होगा अगर मैं k का, in fact फर्क पड़ता है ना, cos function है तो k को minus k करोगे तो the minus sign doesn't come out. Sin function है k को minus k तो sign comes out. Yeah, so rather than thinking too much about trigonometry, bottom line ये है, don't touch the shape, don't touch k, just change omega. That will take care of the direction change. If you want to reverse the if you want to reverse invert the pulse, accordingly amplitude को negative कर लो. Alright, so that's what we see over here. Reflected wave, two changes. What is the change? A becomes AR. Excuse me. A becomes AR and omega ka sign changes. Transmitted wave, A becomes AT, K changes. K becomes K dash. Nothing else. Okay, those are the only changes. All right, we'll see now how to derive AR-AT. Any doubts on this page? Lambda, I just said ki K is inverse, K is 2 pi by lambda, na? So lambda is inversely proportional to mu. So heavier string will have smaller lambda. Heavier string will have smaller lambda and lighter string will have bigger lambda. You don't need to remember that. You can work that out. If you have k is equal to k is proportional to root mu, you can work that out. Okay. Now, so before I show you that page, okay, can we think now? अच्छा, मुझे A, AR और AT निकालना है. मतलब A के terms में AR, AT निकालना है. AR, AT are two unknowns, so I need two equations. Okay. Now, the first equation is a direct relation between these three, A, AR, and AT. Can you guess? Can you think logically what could be a relation between A, AR, and AT? The hint is it's of the form something is something plus something. Logically सोचो, A, AR और AT को something is something plus something के फॉर्म में लिखोगे तो क्या आ जाएगा? What do the others think? Wow, Sanika, that's nice. Wow, Tanmay, nice. Good. I mean, I wonder if you guys have seen the next page, or if you have actually thought of it, then that's really, really good. Because even when I was a student, my bina soch ke, my first guess was A is 80 plus R. My first guess was A. A को यहाँ पे मैंने इस पेज पे A incident लिखा है. So my first guess was A, या incident amplitude is 80 plus AR. ये मेरा first guess था, है ना? So all those who very nice था, very nice. तो ये मेरा guess था, but then you can see कि this is like more like an impulse guess. We just guess कि amplitude, अंदर आने वाला amplitude is equal to reflected amplitude plus transmitted amplitude. But does that make sense? You think of it, there's no such logic. Why should amplitude be conserved? It makes sense to say energy is conserved. You can say अंदर आने वाला power is reflected power plus transmitted power. That makes sense. That's, by the way, our second equation. अंदर आने वाला power is reflected power plus transmitted power. But that absolutely makes no sense for amplitude. So AI is not AR plus AT. And if that was your guess, don't feel bad. That was also my guess when I was a student. First time guess, that was my guess. In haste, गलत है. ठीक है? There's no logic for that. Okay. In fact, ये page का जो equation है ना, this often comes as a theoretical question. What is the relation between A incident, A reflected, and A transmitted? Right. So make sure you understand this. क्या हो रहा है? In reality, we'll have to think of what will the displacement of this particle be. See, because the only way we can hope to equate AT, AI, and AR is by considering the fact that that particle, that point of contact के दोनों side पे जो particles हैं, they should more or less be at the same place. The particles very close to the point of contact should be at the same place at any given instant of time, because they're very close, right? So the pink string ka rightmost particle and green string ka leftmost particle should always be at the same place. Now imagine a condition where, sorry, my undo button is not working. Imagine a condition where these both the pulses, both these particles are at their extreme position. Think what that extreme position would be for the green particle and the pink particle. So for the green particle, uska amplitude 80 hai, so definitely uska extreme position will be at a height of 80 above the mean position. Whereas ये जो pink string वाला particle है, okay, तो उसका वो जब अपने extreme position पे जाएगा, वो जब अपने extreme position पे जाएगा, okay, you can now visualize, so you can visualize this as half. Okay, what is this specific instant? Half the pulse has actually crossed over to the other string. Half the pulse is crossed over and half has already started getting reflected. Okay, so when the incident pulse and the reflected pulse are now present at this instant, both of them are going to add up. Okay, and जैसा reflection from free end में हमने जैसा दिखा था ना, A plus A add होके 2A होता है. That's the incident wave and the reflected wave adding up to 2A. वैसे यहाँ पे क्या हो जाएगा? यहाँ पे as the incident wave and reflected wave, यहाँ का y coordinate will be, यहाँ का max amplitude will be addition of the two amplitudes in this region. The two amplitudes in this region are AI and AR. When they react constructively, the max amplitude this can reach is AI plus AR. उधर क्या पहुंच रहा है? उधर AT पहुंच रहा है, इधर AI plus AR पहुंच रहा है. Right? So that's why AI plus AR has to be equal to 80. AI plus AR has to be equal to 80. So what happens is, as the wave gets reflected, जो incoming wave है वो reflected wave के साथ interact करना start करता है. That position where half the pulse is crossed and half is reflected, you find that particle to have both AI and AR का combination. In other words, that particle reaches AI plus AR. That's the max displacement you see. तो इसके आगे भी जो pulse transmit हो जाता है, that continues with that max displacement. Okay, so AI plus AR is 80. AI plus AR is 80. So you get that by comparing the amplitudes on both sides. ठीक है, यहाँ पे लिखा क्या पढ़ता हूँ, particles at the junction should have the same displacement as dictated by both the strings. So at the junction, the particle should have the same displacement as dictated by both the strings. So the particle ka displacement as dictated by the green string is 80. The particle ka displacement as dictated by the pink string will have to be a combination of the two displacements on the pink string. Now the pink string has two waves. It has the incident wave and the reflected wave. So therefore, uska amplitude will come by the addition of the incident wave ka amplitude and the reflected wave ka amplitude. So wo jo dotted lines मैंने draw किया था, again my undo button is not working, so I'll have to zoom in and erase. But ये जो dotted lines draw किया था, come on. Dotted lines, the orange line is the incident wave, depictive of the incident wave, and the light blue line is depictive of the reflected wave. उनका combined amplitude AI plus AR हो रहा है left hand side पे, and right hand side पे combined amplitude 80 हो रहा है. मतलब right hand side पे एक ही wave है तो उसका amplitude 80 है. So 80 on the right hand side is AI plus AR. This makes sense. Particle having to be at the same displacement. Yes, Yash, you can say that. Yes. So 80 is AI plus AR is equation number 1. Or in terms of the variable I had used in the beginning, AI को मैंने A लिखा था. So 80 is A plus AR. This is equation number 1. You'll see equation number 2. Let me know if you're done copying this page. Any doubts on this page? All right. Okay. So ये एक equation है. Then the other equation we have is the one I mentioned about power. That makes sense. Incoming power is, incoming power is a combination of, incoming power will be split into reflected power and transmitted power. That makes sense. Energy conservation makes sense. So let me zoom in a little bit. Okay, so my power equation is, power by the way was half mu v a square omega square. That's the formula for power. ये याद करना है. It's like the SHM equation where mass has been replaced by mu v. SHM का total energy is half m a square omega square. यहाँ पे total energy is half m की जगह mu v a square omega square. Okay. Power is therefore mu. अभी omega is constant. The power is proportional to mu into velocity into amplitude square. Power is proportional to mu velocity amplitude square. Let's simplify that a little bit more. Velocity can be written as root p by mu. Velocity can be written as root p by mu. Okay, so when I do that, tension is anyways a constant. So I can take that out of the proportionality. Mu by root mu becomes root mu. So now power is actually proportional to root mu a square. Power is proportional to root mu a square. And then root mu being proportional to k, power is proportional to k a square. Okay, so you can just work that out and remember this ki power is proportional to k times amplitude ka square as it's going from one string to another, because as it's going from one string to another, tension and omega are constants. The power is proportional to k square. Now energy conservation tells ki incident power is reflected power plus transmitted power. Okay, so power को मैंने लिखा है as, since it's proportional to k square, I just wrote it as some constant, random constant c times ka square. So incident power is c times ka incident square. Reflected power is c times ka reflected square. Transmitted power is c times k dash a transmitted square. Bear that in mind. For transmission, k is different because this is now a different medium. C was the constant of proportionality. Naturally, that cancelled out from all three terms. Okay. The annoying undo button is not working. Okay. So C naturally cancelled out from all three terms. And then you get KAI square is KAR square plus K dash A T square. Okay, so that is the equation we have finally. Another thing I just did over here was, again, I replaced AI with A. Okay, I've replaced AI with A. Okay, I've taken AI as A. Now, before somebody is, so one of you is asking, sir, do we have to remember the whole derivation? The answer is no. If you get a question on reflection and transmission, you don't have to remember the derivation. I'm going to give you an algorithm on the next page. You just have to follow that. But there are a lot of important theoretical points in this derivation that you should make sure you understand. Maths aside, at least you should understand the two equations. One equation is power conservation. Incident is reflected plus transmitted. Another equation is how AT is AI plus AR. They come as theoretical questions. Which of the following is true? ऐसा question आता है. PI, PR, PT के बीच में, AI, AT, AR के बीच में. So that way the derivation is important. Conceptually it's important. तुम्हें exact maths workout करने का जरूरत नहीं पड़ेगा. You can remember the result. So the derivation is important. Then ये भी जो मैंने बोला, tension fix रहता है, omega fix रहता है. K कैसे रूट म्यू के प्रोपोर्शनल आता है, पावर कैसे K A स्क्वायर के प्रोपोर्शनल आता है. Those things are important. Okay, and those they all build from your basic formulas only. B is all those basic formulas. B is omega by K, B is root T by mu, सब उसी से आ रहा है. ये पावर का फॉर्मूला है. Okay, result finally देखते हैं क्या आता है. So I'm just quickly solving this. This is the math. Of course, ये याद करने का जरूरत नहीं है. This is the math. So K A R square को उधर लेके गया, तो K A square minus A R square आ गया. Right hand side K dash A T square आ गया. So I've rearranged the second equation. Now, if you remember, the first equation was A plus AR is equal to AT. So I have over here A minus A square minus AR square. So I'm getting tempted to divide this form of the equation by equation 1. I'm dividing this by A plus AR equal to AT. तो लेफ्ट हैंड साइड को जब A plus AR से डिवाइड किया तो A plus AR कट जाएगा and I'll only be left with A minus AR into K. I hope you saw that, है ना? The other thing is the right hand side को जब AT से डिवाइड करूंगा, K dash रह जाएगा, AT square में से AT कट के AT रह जाएगा. Okay, so we are just now solving those two equations simultaneously. Now that we have this, K A minus AR is K dash AT. The next thing I can do is I can just use AT. I can resubstitute AT as A plus AR. When I substitute that, this becomes a simple linear equation in AR. Okay, so I get K into A minus AR is K dash into A plus AR. This is all maths. You can cross check and see if it is correct. Okay, फिर AR को right hand side लेके गया, A को left hand side पे लेके आया. तो A लेफ्ट हैंड साइड पे आने पे K माइनस K डैश A हो गया, और AR को राइट हैंड साइड में लेके जाने पे K प्लस K डैश AR हो गया. तो यहाँ से we now have a result for AR. Okay, we have a result for AR. And the formula for AR is K minus K dash upon K plus K dash A. K minus K dash upon K plus K dash A. This is the formula for AR. The formula for AT. So AT I can use this equation now. Now that I have AR, let's use the equation. AT is A plus AR. So when AT is A plus AR, so I have to add A plus AR. AR में A था तो मैंने A और A common लिया. So A becomes A into 1. AR becomes A into K minus K dash upon K plus K dash. Okay. 1 plus K minus K dash upon K plus K dash. LCM ले लिया. 1 को लिखा K plus K dash upon K plus K dash. और फिर ये term था K minus K dash upon K plus K dash. So as you can see, K dash cancels out when you add them up. And the final result is 2Ka. Final result is 2Ka K plus K dash. 2Ka K plus K dash. All right, so that's your transmitted wave ka amplitude. Now I'll summarize these results on the next page. Okay, and I'll tell you exactly what changes you should make. But with this, now we can also see how the results for free end and the fixed end reflection का results इससे कैसा आता है. Yes, Sahil, yes. I divided this equation 2 को rearrange करके I divided by equation 1. Divide by 1. और उसके आगे बस थोड़ा math, इसके आगे maths है. Okay, so you can of course work that out. Nothing to remember here except the formulas, final formulas. But yeah, the steps before this point were all conceptual and important. इसके आगे is just basic solving, काटा फूटी. ठीक है. ओके, ये जो रिजल्ट है इससे देखो कैसे फ्री एंड का रिजल्ट आता है. सो व्हेन आई टॉक अबाउट दिस, स्पेशली दिस वन, रिफ्लेक्शन का ये जो फॉर्मूला है वो एक बार देखो. व्हेन आई टॉक अबाउट रिफ्लेक्शन फ्रॉम अ फ्री एंड में there is no opposition to the oscillation of the string. You can almost imagine as though the string is attached to a very light string. This string is attached to an infinitely light string. If it's attached to an infinitely light string, it's almost the same as reflection from a free end, because that light string is not going to hinder the motion of this heavy guy in any way. Heavy string will not even come to know the light string is attached, right? So if the second string is incredibly light, if the second string ka linear mass density tends to 0, and thereby K dash, which is proportional to root mu, also tends to 0, use limits and see what this result becomes. If K dash tends to 0, AR is equal to K by K times A. K will cancel out. AR is equal to A. So when the string is infinitely light, your result, your reflected amplitude tends to be the same as your incident amplitude. This is why when you have when a pulse gets reflected from a free end, you get an upright pulse of the exact same amplitude. Why are we saying this is upright? Because this result is positive. AR is the same as A. Okay. What happens when I have how do I visualize reflection from a fixed end? So fixed end में क्या होता है? This end of the string does not move. You will expect to see that happen if you see a light string attached to an infinitely heavy string. Right? So light string का oscillation के कारण ये heavy string हिलेगा ही नहीं, hardly हिलेगा. So the second string is infinitely heavy. You will expect to see any reflected wave produced in this guy produce as though it got reflected from a fixed end. फिक्स्ड एंड के लिए दूसरे स्ट्रिंग को इनफाइनाइटली हेवी कर दो. इनफाइनाइटली हेवी करने का मतलब, okay, this is all just visualization. You don't, of course, not going to use this, but when you make the second string infinitely heavy, when u dash tends to infinity, when k dash also then tends to infinity, look at the result that you get. Limits में, if k dash is tending to infinity, k is negligible. If k is negligible and you cancel out k dash, the ratio is going to be -1. So AR becomes minus A in that case. So when you have an infinitely light string, sorry, yeah, if you have reflection from a fixed end, when your wave goes from a light string to a very heavy string, your reflected wave is going to have an amplitude of -A. Means it's going to have the exact same amplitude, but it's going to be upside down. Okay? So this is a way we can at least mathematically prove the result for free end and fixed end. Okay. And then one of you is asking, sir, why at free end is the resultant amplitude 2A? Free end के reflection में तुम्हारा reflected wave का amplitude A होता है और incident wave का भी amplitude A होता है. So for that brief instant, you can see them combine. You can see them interfere constructively, and reflected wave का A and incident wave का A मिलके two-way हो रहा है free end में. When they're combining, right? When they're combining, reflected wave and incident wave का मिलके A plus A two-way हो रहा है. और fixed end में उल्टा है. Fixed end में reflected wave का -A और उसका +A combine होके 0 ही होता है और हमेशा उस end का displacement 0 होता है. Any doubt on this page? I'll show you the algorithm now. Okay, finally you have to follow those, I think, 6 steps of the algorithm that I've written on this page. 6 steps, simple steps. How you can, in a structured way, go from an incident waves equation and get the corresponding reflected and transmitted wave equations. Okay. Okay, chalo. Nobody is saying wait. होने पे बता दो. Yeah, sure. Fixed end. So थोड़ा imagination चाहिए fixed end के लिए. Yeah, those who are copying, please continue copying. Finish that. I'm just explaining the fixed end thing. So fixed end के लिए visualize a little bit. If your wave passes from a light string to a very heavy string, okay, very heavy string, तो वो heavy string तो ज़्यादा move नहीं करेगा इस light string के oscillation के कारण. तो because heavy string move नहीं करेगा ना, वो जो light string से जो reflected wave आएगा, that will be as though reflection has taken place from a fixed end. Okay, this end is going to be more or less fixed if that second string is very heavy. Okay, and with this we can hope to see the result for the amplitude of the reflected wave when reflection takes place from a fixed end. What we'll do, ये जो formula आया, इस formula में हम second string को बहुत भारी कर देंगे. Second string को भारी करने का मतलब उसका linear mass density infinity डाल दिया and k dash को भी infinity तक लिया because k dash is root mu. So k dash also tends to infinity. When that happens, use your concept of limits. What does this tend to when k dash tends to infinity? K is finite, k dash is tending to infinity. K dash के सामने k is negligible. काट दिया k को, k is negligible, क्या रह गया, माइनस k डैश बाई k डैश, कैंसिल कर लो माइनस k डैश बाई k डैश को, कैंसिल करके माइनस a मिल रहा है, समझ में आया? तो when your string, when your pulse bounces off a very heavy string, your reflected wave is inverted. A very heavy string is almost similar to as though your wave bounced off a fixed stem, because in the case of the heavy string, that point of intersection is not going to move, hardly going to move. So almost like reflection of a fixed stem. The wall is like a heavy string. हो गया जिसने वेट बोला था? वाओ, क्या लिखा है? अरे पेज, अच्छा देखो, this is the algorithm, so this is ultimately what you need. All right, so given yi is a sine kx minus omega t, given the incident waves equation, also what else will be given? Given mu and mu dash. Okay, you'll also be given mu and mu dash. You'll be given the linear mass density of the first string and the second string normally. Okay, first thing you should do is when you see this equation, find k. तो बहुत सिंपल है, उधर आंख के सामने ही दिखेगा. Find k. So find the, for the incident wave, find k. Find coefficient of x का magnitude in yi का equation. Coefficient of x का magnitude, okay, ignore the sign, in yi का equation. So you'll get k for the first string. Okay, then come on, undo button. Thanks, yes. Now find k for the second string. So when you find k for the second string, okay, when you find k for the second string, you can use the formula k is proportional to root mu. So second string ka k dash is root mu dash by mu times k. So this is again very simple. This is just ratio proportion. Apply ratio proportion, apply k being proportional to root mu to get k dash for the second string. So for this, you need to remember k is proportional to root mu. K dash is root mu dash by mu into k. तो दोनों स्ट्रिंग का k और k dash आ गया, मतलब दूसरे स्ट्रिंग का k dash आ गया, पहले स्ट्रिंग का k मिल गया. इसके बाद k और k dash के टर्म्स में अपना फॉर्मूला है. So then I'm saying find AR. Okay, find AR, and AR का फॉर्मूला यहाँ पे लिखा है. So you will use the formula. Please, it'll help to remember it. You wouldn't want to do that entire derivation I did in the exam. So definitely, please remember this. Okay, if you want to quickly solve a question like this in the exam. So AR का है k minus k dash upon k plus k dash. And you can always, check. You can जैसे लोग को normally ये याद रहता है, most part याद रहता है. Sometimes what will people have a doubt in? They'll have is it k minus k dash or is it k dash minus k? वो ऐसा डाउट हो सकता है. For that, put k dash as 0, and you know कि when the second string is very light, you should get a as the answer, free end की तरह. So you can use those kind of, that's the point of these extra demonstrations I gave. If you remember the formula somewhat, but don't remember exactly whether it's k minus k dash or k plus k dash, check. Put k dash is 0, AR should be a. Put k dash is infinity, AR should be minus a. So with that, you can, eliminate some of the wrong formulas you have a doubt. Find AT. AT is 2k a upon k plus k dash. That's the fourth step. तो फॉर्मूला के हिसाब से AR AT निकालना है. फॉर्मूला प्लीज याद कर लो. फॉर्मूला प्लीज याद कर लो. ओके, फिर step 5, for the reflected wave, you have to make two changes. First is, of course, as I have stressed, this is the most important thing, replace omega by minus omega. That will take care of the change in direction. Reflected wave ulta jata hai. Just replace omega by minus omega. Okay, it doesn't matter if Omega is already negative or omega is positive. It doesn't matter which term is negative, positive. Just change the sign of omega. Change the sign of whatever's in front of omega. उसके बाद वो एक चेंज है. दूसरा चेंज है ऑफ कोर्स AR निकाला है ना, यूज करने के लिए ही निकाला है, तो रिप्लेस A with AR. So this is how your reflected wave equation looks. ओमेगा का साइन चेंज किया, A के जगह AR. And similarly, transmitted wave के लिए K के जगह K dash. Remember, it's a new string. New string has a new mu and a new K dash. K के जगह K dash आ गया. And दूसरा चेंज है ऑफ कोर्स A के जगह AT यूज करना है. Transmitted wave का amplitude यूज करना है. That's it. Those are 6 steps. Very simple. Yeah, it's just a structured way of figuring out K from the equation, finding K dash, finding AR, AT, and then writing the reflected and transmitted wave equations. Okay. और यहाँ पे मैंने क्या लिखा है इधर साइड में एक बार थोड़ा देखते हैं. Okay, so I've written note the reflected pulse gets inverted when the pulse is incident from a lighter string onto a heavier string. All right. So what I was saying is, if you look at this equation for AR, okay, this equation clearly shows that AR can be positive or negative based on if K is bigger or K dash is bigger. This one will always be positive. There's no option for this guy to be negative. So the first one can be positive or negative based on whether K is bigger or K dash is bigger. For instance, if K is smaller, if K is going to be smaller, AR is going to be negative. K कब smaller होगा जब पहला string light होगा. So the reflected pulse gets inverted. AR is negative when pulse goes from a lighter string to a heavier string. Heavier string में reflection हमेशा invert हो जाएगा. Heavier string में a reflected pulse will always be inverted. Sorry, heavier string से reflection हो रहा है to an inverted pulse. I'll try that again. Heavier string से reflection हो रहा है तो a pulse will always get inverted. The reflected pulse will always be inverted. And to remember that, just make the string very heavy and you will remember that it is like a fixed end. तो fixed end में inversion होता है, वैसा ही heavier string के साथ reflection में भी inversion होता है. The heavy string is like a fixed end in a way. Okay? Extreme case of a heavy string is a fixed end. However, there is no inversion if the reflected pulse, there's no inversion in the reflected pulse if the wave is passing from heavy to light. Okay, so when the wave passes from the heavier string to the lighter string, K बड़ा होगा K dash से और AR positive होगा. So भारी string से light string में no inversion. Why is there no inversion in the reflected pulse? You can just remember that as heavy to light. उसका extreme cases like reflection from free end, no inversion. These are, of course, I mean, there are, some of these points are repetitive, or rather, you can look at it as reinforcing. You know, some of these points, if your mind grasps them, it reinforces the formula you know. So if you're confused with one or two terms in the formula, you can remember these things and see whether your formula is correct or wrong. You should see K minus K dash and AR. K जब ज़्यादा है, no inversion. K जब कम है, inversion. Okay. Now let's do some question on this. Let me know when you guys are done copying this page. फिर इसमें question देख सकते हैं. हाँ, लिख के हो गया तब बोल दो. लिख लो, होने तो बताओ. Some are done. बाकी में जिसने वेट का है जैसे हो गया. By the way, even those who didn't have a lot of doubts in the from the HCV, still I would say just for once check that video that I've shared. Yeah, whenever you find time, try to see that. Maybe you may see a couple of things or get some insight which you probably didn't have before. Okay? All right. So, yeah, ये question कर लो. Don't look down. Okay, so I have two strings. The red string is the heavier one, and the incident wave is on the red string. Again, I hope I can erase this black marker later. But हाँ, red string से green string में wave जा रहा है. Red string का linear mass density is 4. Green string the linear mass density is 1. The equation of the pulse, incident wave is, I've drawn a pulse, it's actually wave. The equation of the incident wave is 4 sine 3x minus 4t. Please follow your algorithm and find yr and yt. Very simple. Sorry, I'll just reconceive that. Yes, simple hai. Par, that's right. Let me also add here, based on the algorithm, this will like seem like a very easy question. So that doesn't mean they'll try to complicate it further, because on paper, this is not an easy question. It's easy because you have the algorithm and you have the formulas. But like when they ask you this question, they'll think a student who knows their concepts but doesn't know the formula is going to probably take some time to derive AR and ET and get YR and YT. So that's what they'll think. Right? So from their point of view, this is a good question. So only good students can, actually do all of the derivation, find AR, find AP, conceptually write the correct equation. So yes, it's easy with the formula, but don't expect any more complication, because from scratch, this is a tough question from scratch. Okay, not everyone knows an algorithm like that. Some people derive from scratch. Yes. मतलब जेई सच जेई एग्जाम का ऐसा है कि एग्जाम बेसिक कंसेप्ट्स पे बेस्ड होना चाहिए, एनसीईआरटी कंसेप्ट से बेस्ड होना चाहिए, बट उसका एप्लीकेशन कुछ भी है ना, अच्छा अच्छा कुछ भी अच्छा एप्लीकेशन उसका हो सकता है. सो इट्स लाइक it should be in a way fair for a poor person who probably can't afford coaching but is really brilliant, who knows his concepts well, and based on that, if he gets a question like this, he should still, given the 3-minute, 4-minute time frame, we should still be able to solve. So that's the idea with you. And those who set the JEE paper are not coaching institute teachers, so they probably don't know what shortcuts teachers and books are coming up with these days. Means level नहीं यार, ये advanced level है. Come on, means level थोड़ी. कितना भारी concept है ये. वो algorithm को use करना means level जैसा हो जाता है. But the concept is so rich and so beautiful. Getting all of this down, changing omega. This is a good advanced level question. I just said they'll probably assume. Why will they consider this an advanced level question? They'll assume that yes, Parth, yes. So they'll assume you're working from scratch. They don't know all these people nowadays come up with shortcuts. Your JEE paper setters are IIT professors. Conceptually, ये तो बहुत सही question है. Yes, the algorithm does make it a little unfair and makes it very simple, but hey, advanced level question है. इससे ज़्यादा variation नहीं है. Okay, so k is equal to 3. All right, k is equal to 3. How do we see that? We just have to see the coefficient of x. That's 3. Fair enough. K dash ke liye we have to use root mu dash by mu into k. So mu dash for the second string, the linear mass density is 1. Okay. For the first string, the linear mass density is 4. So k dash is going to be root 1 by 4 times k. तो वहां से दूसरे स्ट्रिंग का लीनियर मास डेंसिटी आ जाएगा. The ratio proportion is going to be 3 by 2. Okay, mu 1/4 था तो k 1 by 2 times हो गया. k is proportional to root mu. फिर फॉर्मूला में डाल दिया ar. ठीक है, imagine कि you had to derive the formula. Immediately it becomes a good question. ठीक है, फॉर्मूला में डाल दिया ar, k को डाल दिया 3, k dash को डाल दिया 3 by 2. So 3 minus 3 by 2 upon 3 plus 3 by 2 into 4. ठीक है, so that becomes 1.5 upon 4.5 times 4, and therefore this result becomes 4 by 3. Yeah, by the way, I do know a lot of good students, and in fact some of the people I used to study with, we didn't really normally memorize this formula. We just had a habit of leaving some things to deriving in the exam. So normally utna thoda sa time rehta hai. If you're fast in other things, you kind of have the time to make these derivations. So certain things we would not memorize. So at least like for people like us, you know, it does become a good question if we have to derive these results and get the right results. Okay. Anyways, you can use the formula if you remember it. So AR is 4 by 3. AT is 2k upon k plus k dash a. K is 3, k dash is 3 by 2. So 2 into 3 upon 3 plus 3 by 2. 6 by 4.5 times a. Okay, that's 4 by 3 times 4. So 16 by 3. So AT is 16 by 3. Okay, you don't need to think about whether a minus sign and all should come. The formula takes care of whether a minus sign should come or not. Okay, यहाँ पे no minus sign means no inversion in the reflected pulse. Okay, so finally our answer is YR is AR लिखो 4 by 3. Sin KX लिखो. ठीक है, सेम फॉर्मेट कॉपी करो. ओनली चेंज इज t का कोएफिशिएंट का साइन चेंज करो. तो 4 के जगह -4 के जगह +4 कर लो. -4 के जगह +4 कर लो. Okay, and also be careful if your equation is written in this form 4t minus 3x. Don't make this plus. Okay, be careful. t का कोएफिशिएंट ही चेंज करना है. 4t minus 3x minus 4t minus 3x हो जाएगा reflected wave के लिए. It's okay if there are extra minus signs. It's okay if there are 2 minus signs. You can even take them out later, but only change the quotient of t. Yt similarly, a के जगह 16 by 3, and only other changes k के जगह k dash, 3 के जगह 3 by 2. बाकी exactly the same. Okay. All right. So ठीक है, बस तो ये 51 तुम होमवर्क के लिए कर लो. एटलीस्ट 51 कर लो. कल आई थिंक वी मीटिंग टुमारो ओनली, सो देयर इज वन क्वेश्चन. सॉल्यूशन भी उधर ही है. ठीक है, तो look 51, look up 51 on the drive and solve that at home. We can just quickly discuss that tomorrow. And now with that, we'll then in the next class we'll Uh, then we'll continue with standing waves. Okay, so we have almost, in fact, we have finished traveling waves, and in the next class we'll see, tomorrow we'll see something else called as a standing wave, which is again very, very simple, and that will also get over pretty soon. Okay. All right, then, so I'll see you. Bye. Welcome. I'll discuss HCV 33 tomorrow. So if you haven't attempted question 33, please try that. Okay, I'll discuss that tomorrow. And बाकी 33 के पहले जो भी मुश्किल questions थे, those are anyways present in your WhatsApp group, the link that I've sent. You can check them out for any question before 33. 33 I'll discuss tomorrow. So just have a look at that. 33 थोड़ा अलग है, वो समझा देता हूँ. हाँ, okay, those who want to leave can leave. Those who have doubts, you can ask some doubts. Sir, on slide 51. Slide 51. Twisting the sign. You mean 50, I hope. 51 homework now. 50. Yes, I'll just reply. एक second. इसका खत्म करने दे. Can I repeat the twisting the sign? Twisting the sign. ये वाला white. अच्छा 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 अच्छा. ये जो मैंने बोला था कि अगर इंसिडेंट वेव, I said इंसिडेंट वेव का इक्वेशन अगर तुम्हें दिखता है ना, 4 साइन ऐसा दिख गया, 4t minus 3x, ठीक है. और मैं बोल रहा हूँ कि अगर तुम्हें रिफ्लेक्टेड वेव का इक्वेशन लिखना था, ठीक है, तो a वगैरह निकाल दिया 4/3. So again, it's just the repetition of what I stressed earlier today as well. Do not change the sign of k. In other words, don't change the sign of whatever's in front of x. Don't write this as 4t plus 3x. Okay? Change the sign of what's in front of t. Change the sign of omega. तो ये -4 हो जाएगा, वो -3 रह जाएगा. ये तुम्हारा आंसर है. Let there be 2 minus signs, that's okay. But only change the sign of t. Don't change the sign of x. वो बहुत इंपॉर्टेंट कंसेप्ट है. बाद में ऑप्शंस में अगर पूरा का पूरा माइनस साइन बाहर लिया तो वो भी चलेगा, माइनस साइन बाहर जाने दे. बट let this be the change you produce. Change the sign of the coefficient of t. Clear है? No. Can I please, it's है ना. Yes, I'll reply. Can I please explain the amplitude equation reasoning? अच्छा. Amplitude equation reasoning. You mean this one? So this one is just, I'm just saying कि particle के right hand side पे एक ही wave है, right hand side पे A transmitted है ना, और left hand side पे दो wave है. So left hand side is not just A incident or it's not just A reflected. These are continuous waves. So the left hand side is a combination of A incident and A reflected. Even in a room when we talk about the effects of reverb, so the reverb ka effect is your sound interfering with the reflected sound, and that kind of gives us the effect of being inside a room. Or if you sing into a mug, then you get a very quick reflection. So that's again, that gives a different kind of reverb. So यहाँ पे on the left hand side you have a combination of the incident pulse and the reflected pulse, जिसका amplitude will go up to AI plus AR. Right hand side is a combination, is just the transmitted pulse, जहाँ पे amplitude will go up to 80. Now when these are at their extreme position, you should see the particle have the same, the point of contact have the same displacement. Point of contact ka ye right wala, just the particle next to it has a displacement of 80 as dictated by this equation. The particle just to the left of it has a displacement of AI plus AR as dictated by the resultant amplitude on the left hand side, which is a combination of the incident and the reflected pulse. And both these displacements should be the same. That's the only way the green end and the red end can be in contact. The green end ka 80 hai, red end ka AI plus AR hai. That's why 80 is AI plus AR. Got it? Diagram mein, pink string is the resultant. The orange dots are the incident wave and the light blue dots are the reflected wave. Yes, Disha, yes. And they'll be together. I mean, reflected wave will, see, you should understand that the reflected wave will start as soon as the incident wave has reached there. So incident wave जब इतना आगे गया ना, उतना आधा reflection start हो गया. Okay. अब incident wave जब exactly half cross कर चुका है, reflected wave भी half enter कर चुका है. So I'm actually drawing that case. When half of the incident pulse has crossed over to the other string and half of the reflected pulse has now been reflected into the string. So at this instant, your incident pulse and your reflected pulse are combining and reaching a total amplitude of AI plus AR. This is just the way in a free end they combine and reach a total amplitude of A plus A. जैसा वो 2A पहुंचता है, कब 2A पहुंचता है? That's when half of your incident pulse and reflected pulse have combined. यहाँ पे वैसा हो रहा है, AI and AR combining and reaching a total of AI plus AR. Okay, cool. That's it.